A conservation scientist implemented a program to reduce the population of a certain species in an area. The given function estimates the species population X years after 2008, where X is less than or equal to 8. Which of the following is the best interpretation of 3000 in this context? So if you didn't know and were approaching this from scratch, you could graph this. Let's see if we can do this just the Desmos way and get that to give us some helpful information to begin with, like this. Now, of course, you will have to adjust the window and understand the meaning of this. But if you zoom way, way, way out, of course, it's not really set up for people to do this, but if you zoom way out, you will see that this is the point 0, 3000. So when you put in 0 as X, you of course get 0.75 to the 0, which is 1, times 3000 is 3000. So you have the point 0, 3000, which is the y-intercept, which is effectively the starting point. And it tells you that since it's years after 2008, the meaning of 0 as X is simply the year 2008. So in 2008, the population was 3000, which should be the estimated initial population for the species and area in 2000. I'm sorry, I meant to say in 2008. The given equation relates the variables X and Y. For what value of X does the value of Y reach its minimum? So this is a classic situation where if you know the rules, the special attributes of a quadratic, the axis of symmetry is always negative b over 2a. I can quickly give the long form explanation for that. So if you remember from the quadratic formula, if you have a parabola like this one on the left is negative b minus root whatever over 2a, and this is negative b plus root whatever over 2a. And I say the whatever because these end up canceling out when you add them together, but let me write it the long way. If you were to take the sum of the roots and you literally add these together, you get this plus this. Now, again, I'm not writing what's in the radicals because they cancel out. If you think about adding fractions that have the same denominator, you get to here, and then the minus root and the plus root cancels out, which gets you to here, which gets you to here. So the sum of the roots in any quadratic is negative b over a. Now, the axis of symmetry in any quadratic is halfway between the roots. So I'm going to write this out in words because we have time here, because we're going relatively quickly on this section, of course. Axis of symmetry is halfway between, right at the edge here, halfway between roots. Now, halfway between geometrically is the average of the roots. I realize I'm not writing this very, very neatly, but the average of the roots is the sum of the roots divided by 2. Now, this is itself the sum of the roots. So it's negative b over a as a quantity divided by 2, which, remember that dividing by a number is the same as multiplying by its reciprocal. So in this case, the 2 gets tucked on the bottom, is negative b over 2a, or more properly, it's the vertical line, x equals negative b over 2a. That's the axis of symmetry in any quadratic. That's extremely helpful to know. In fact, for a lot of people, that topic alone provides a pretty decent bump up in their score once they master it. So, for what value of x does the value of y reach its minimum? The minimum of an upward opening parabola is, of course, the y value of its vertex. The x value is negative b over 2a, which is 14 over 2, which is 7. Now, of course, you could jump over all of that by having simply put it into decimals, of course. And if we go all the way back to much more standard graphing here, you can see that Oh, so sorry. So sorry. I miscopied with the X. So sorry. Here we go. Has vertex at 7. Yeah, 7 comma negative 27. So the answer is 7. Square A has side lengths that are 166 times the side lengths of square B. The area of square A is k times the area of square B. This is a tricky question because a lot of people would accidentally say 166, but that's not how square variation works. When in doubt, think of a much simpler example. If the old one was a square of edge length 1, of course the area would be 1. And then if the new one was a square of edge length 5, the area would be 25. So when you increase the linear edge as a multiple of 5, you increase the enclosed area by a multiple of 5 squared. So it's 25 times as much. In this case, the answer is actually 166 times 166. It's a bigger number than you're expecting it to be. The answer is 27,556. This is a system of equations. A lot of times it's set up so that if you simply add or subtract them, it collapses to be something basic. In this particular case, that happens to be true because you have the same thing in the A columns. So if you simply subtract the bottom equation from the top equation, it collapses to be something simple. Now, subtracting the bottom from the top, some people like to think of it as -1 times, and then you add them. That's, of course, the same thing. I think of it as simply subtracting in place. So this cancels out to nothing, and this gives you 4b equals 100. So b itself is 25. It works out to be a nice, neat number in this case. The function f is defined as that. What is the y-intercept of the graph of that in the xy plane? Well, the definition of a y-intercept is the thing you get when you plug in 0 as x. Now, according to the order of operations, the exponent applies only to the 2. So 2 to the 0 is 1, times -8 is -8, and -8 plus 22 is 14. So it's 0, 14. Of course, you could graph this on Desmos. You just have to be very careful of understanding the parentheses here. So if I copy it exactly as written, that should work because there are implicit parentheses around the quantity 2 to the x. Although if you wanted to be extra careful, you could actually go like this just to prove the point. And then you have 0, 14. Two variables x and y are related such that for each increase of 1 in the value of x, the value of y increases by a factor of 4. A factor of 4. By a factor of 4, they mean it multiplies by 4. Now, it gives you a seed value to begin with. So when you have x and y, it tells you that you begin with 0, 200. Now, let's carefully read what it says, such that for each increase of 1 in the value of x, the value of y increased by a factor of 4. So this would be 800. And then 2 would be 3,200. And 3 would be 12,800. So you could basically check by example. Suppose you use this true pair to confirm which answer choice works. So for example, if A is an apple was the right answer, do you get 12,800 when you do 4 times 3 to the 200? Well, no, of course not, because this alone is a ridiculously large number. Do you get 12,800 when you do 4 times 200 to the 3? Well, you could confirm on the calculator, but that's much, much larger of a number than what we're looking at for 12,800, okay? Do you get it when you do 200 times 3 to the 4th? Well, 3 times 3 is 9, so 3 to the 4th is 81. Is it true that 200 times 81 is no? Closer, but no, because this gives you 16,200. So it's got to be D as in dog. Do you get 12,800 when you do 200 times 4 to the 3rd power? So that's 64 times 200, sure. The 2 in the 64 makes a 128, and you add 2 zeros, so it's D as in dog. We just basically confirm that by writing out some examples. What is the value of sine of 42 pi? Okay, so now you're in the realm of trigonometry. Now, I believe you could simply put this into Desmos. Just have to understand how to put it into the correct, is 0. And, well, 0 is the answer. Let me graph f of x equals sine of x. And then if you wanted to, you could actually go rightward all the way to 42 pi. So for people who've taken, rightward all the way to 42 pi, which means I should adjust the tick marks to, yes, I can go all the way to 41 pi, and 42 pi gives you 0. For people who've taken trigonometry or who want to be more adept with more complicated unit circle questions, it's always helpful to remember, or hit on the calculator if you're not sure, but honestly, to remember the sine wave. The sine wave has a period of 2 pi. So if this is 0, 0, this is 2 pi 0. So any multiple of 2 pi is a complete sine wave later. And since 42 is an even number, 42 pi is a multiple of 2 pi. So the answer is simply 0. Okay, this looks a little bit more complicated. H is a constant. If the system has no solution, what is the value of H? The system has no solution. Well, watch what happens when we solve them both for Y. So if I take the top one, I'm going to put the 4x minus 5 on one side and get 18y, and then divide everything by 18. So this becomes 2/9 x minus 5/18. I set that aside momentarily. The other one, when I go to solve for y, I know I'm going to kind of flip left and right here because I happen to have written this way. I divide everything by h. So this is 4 over h as the coefficient in front of the x plus 2 over h. Now, if this system has no solution, so if a system of 2 lines has no solution, that means that the lines must be parallel because solution is where they intersect. So if these never intersect, then this has to be this. So if 2/9 is 4 over 8, 2h is 36. Answer is 18. Now, could you have achieved this also on Desmos? Yes. In fact, Desmos has an amazing feature that lets you do this very smartly. If I leave that momentarily, just as is, and say hy is 2 plus 4x, it offers me a slider for h, a slider. So let me go back to the origin and, of course, probably reset this to just 1. I'm going to reset all the way to -10. Actually, I happen to know that the answer is 20 here, so let me go. Okay. Going all the way back to here now, if I add a slider for h, this is actually an amazing feature. It lets you maneuver this until you create the situation where they are parallel, which of course means that there's no solution. Now, I've kind of hit the limit. You have to understand how to adjust this. I'm going to bump it so it could go up higher to 20. So from 0 to 20 with a step of 1. Sure. Then I spin and spin and spin, spin. You can tell that when you get to 18, it looks like it locks. Yeah, it locks to be perfectly parallel. Probably recommend doing it by hand, but this is an amazing feature of Desmos. One solution to the given equation can be written as 1 plus radical k, where k is a constant. So this is a quadratic that cannot be factored by hand because there are no pair of integers that multiply to -9 and add to +2, which means you have to do the quadratic formula. You have to do this the long way. You could also use Desmos to your advantage, although it's going to be a little bit confusing in this case. I would highly recommend that people actually know how to write out the quadratic formula. So this is this, and this. So 2 plus or minus the root of, this becomes 4 plus 36 over 2. So 2 plus or minus root 40 over 2. Now root 40 is itself reducible by radical reduction. Root 40 is the root of quantity 10 times 4. So root 40 becomes 2 root 10. And then this simplifies all across. I'll write out the factored way of thinking of it just to be crystal clear. And these cancel to 1 plus or minus root 10, which of course matches with what's in the answer choice of a 10. Now, if you didn't know that, suppose you go all the way back to actually graphing the function x squared minus 2x minus 9, and you can get it to show you a 0. Now, of course, this 0 is not really applicable because 1 plus root k could never be a negative number. So it's effectively this one that you're dealing with, 4.162. So I'm just going to call it 4.162. So if you had done this by graphing, is approximately equal to 1 plus radical k. And if I subtract 1, I'm looking at this being approximately equal to this. And if I square both sides, it's approximately equal to 3.162, which you can confirm on the calculator is about 10. Okay, last question. Okay, this is by far the hardest question on the section. By far. This is much, much trickier than anything else on this section. Now, it's not impossible if you recognize what's happening here. Just from experience, I recognize that this must have something to do with the rules of binomial sum and difference and difference of squares. But I'm going to write this out really carefully. So I'm going to put, which of the following is one of the solutions, as in solving for x. Now, since this and this, since the item on the left and the first item on the right are over the same denominator, I'm going to put these on the right-hand side on the first step because they're over the same denominator. So I could do this. Now, this thing as a unit is in the form a over root a. A over root a is a to the first over a to the half, which is itself a to the 1 minus a half, which is a to the half, which is the square root of a. It's just that in this case, a is something that has multiple elements inside of it. So this is going to collapse to be something workable. It's quantity x squared minus c squared to the first, of course, over quantity x squared minus c squared to the 1/2. Now, in that situation, you simply subtract the powers. So this is all to the 1 minus a half, which is, of course, to the half, which is the same as the root of quantity x squared minus c squared still being equal to 39. And then from here, it's relatively straightforward. You square the entirety of both sides. Then in order to solve, to have the x's in the answers, you're effectively solving for c. So I'm going to put this on this side. Oh, I'm sorry, I said it the wrong way. No, they have the c's in the answers, so you're solving for x. Okay, so I should have done it the other way. I should have done x squared equals 39 squared plus c squared. And then lastly, in this situation, it would have been plus or minus the square root of this as a unit. So technically, the solutions are either the opposite of the square root of the quantity 39 squared plus c squared, or positive the root of 39 squared plus c squared, which is, D as in dog.